This final question is quite a bit more challenging than any of the other ones that we've looked at, and I've deliberately put this one in to push those people that feel like they're kind of all over this trigonometry stuff. So this one in particular is one where you may want to stop the video at various times and see if you can proceed on your own, but you know, you may need to at least watch the start of the video to get a feel for where we're going. So in this particular one, I've got two unknowns. Okay, the one thing that makes this question difficult though is I only know one length, and it's not the edge of a right-angled triangle. Okay, this triangle here is not a right-angled triangle. I should have marked it into the question, but this one here is. But this one's not, so I can't just use 1030 and somehow find this side over here, because we're not working with a right-angled triangle on this right-hand side. What we're going to have to do with this one is develop a couple of equations and solve them together to find the answer that I'm interested in. So let's have a go at doing that. On the left-hand side, so this triangle in here, I have a pronumeral here that is opposite the known angle, and I have another pronumeral that is adjacent to the known angle. So if I wanted to set this up, I'm going to be talking about tan here. And that's going to be equal to the opposite side divided by the adjacent. So we'll put that into our calculator, 60 degrees, and find tan of that number. It's quite an awful looking thing. Okay, so 1 point, let's go 3 decimals, 732 is equal to h on x. Now I'm just going to tidy this up. I'm going to take the x across to the other side, so I get 1.732 lots of x equals h. Okay, so that is one equation relating x and h, and I'll just call it number 1 over to the side here. We'll refer to it in a bit. What I'm now going to do is I'm going to think about this larger triangle. Okay, and I mean this triangle along here. I'm not tracing very well, but hopefully you get the idea. Okay, so this whole larger triangle has an angle of 30 degrees in it. Now, the one that was the opposite for the other triangle is also the opposite in this triangle. It's still opposite that one there. But the adjacent side is this whole edge along here. Okay, from here to here. Okay, and that distance has to be whatever x is plus 1000. And I need to work out, again, the trig ratio I'm going to be using. For this one also I'm going to be using tan because I've got an opposite side and an adjacent side for this triangle. So let's work that out. Tan of, this time it's going to be 30, is going to be the opposite side, h, divided by x plus 1000. Again, let's work out what that number is. This time we're working 30 and finding tan of that number. Okay, I get 0.577. Again, we'll go to 2 decimals. It's pretty good. H on x plus 1000. Okay, almost there. What I'm going to do now, as I did before where I multiplied the x up to get it off the denominator, I'm going to do the same thing here. We've got to be careful though because we've got two things we're multiplying, so I need to write them in as brackets. So 577 outside of this thing in brackets, x plus 1000 equals h. Alright, so we're going to call this equation number 2. And we're going to have a look at our two equations. So equation number 1 relates x and h. Equation number 2 also relates x and h. And I need to determine what each of those things are, what x is and what h is. And it's got to be the same thing in both equations because it represents a real distance here. So what I'm going to do is something called solving these simultaneously. I'm going to use one of these equations to knock out the h in the other equation. So have a look here. This statement is saying that 1.732 times x is the same number as h. And in reverse, h can be replaced by 1.732x. So that means I can replace this h in this other equation with this bit here from this equation. Because this equation says these two are equivalent, so I'm going to replace this with this, if that makes sense. So let's rewrite this equation down here, but I'm going to replace the h with 1.732x. So we'll rewrite that. 0.577 outside of x plus 1000 equals, and I've forgotten already what the number is, 1.732x. Alright, and now I have an equation just involving x's, so I can solve this. I'm going to expand this left hand side, 0.577x plus 0.577 times 1000 is going to be 577. This number is still 1.732x. I need to get all my x's onto one side. I'm going to subtract this one from both sides. So I'm going to get 577 equals 1.732x minus 0.577x. A lot of decimals there, I'm not going to risk it, and I'm going to use my calculator. 1.732 minus 0.577, and I get this 1.155x is equal to 577. Finally, I need to solve for x, so I'm going to divide by 1.155. .577 divided by 1.155, and I get, I'm going to round it to the nearest whole number because it's nicer. X is going to be equal to 500. That's an approximate number. So my x value in this equation, this distance along the bottom here, is 500 meters. Now we should also find out what h is. The easiest way to do that is just to use equation 1 again. Okay, so I know h in terms of this thing, so substituting into equation 1, let's remember what equation 1 was. It was 1.732x. Oh, my thing is not scrolling. 732x equals h. I know what x is now, so I can just substitute it in. So let's go 1.732 times 500, and I get that h is equal to 866 meters, which I can write onto my diagram.